other chemical properties do they have? They have 3 valence electrons. They have 3 valence electrons. That's why they are put in group 3. So aluminum has 3 valence electrons. Let's start with boron. Any member you choose will suffice. So here we have boron. Electronic configuration 1s2, 2s2, 2p1, right? Now you can see boron here has 3 valence electrons. And how do you determine that? By giving the sum total of the indices of the second energy level. So here you have 2 plus 1 gives you 3, which tells you it's a group 3 element. And our boron is a group 3 elements are p block. Why? Because their last electrons fill the p suborbital. Unlike groups 1 and 2, which are s block elements. If you take the electron configuration of groups 1 and 2 as we did, you would see that their final electrons were positioned on s block, either 1s, 2s, 3s, 4s or so, but they are s block elements. But for group 3, they are p block elements because the last electrons are positioned on the p suborbital. Now, they have 3 valence electrons, as you can see. The same thing for aluminium. Aluminium with an atomic number of 13 has 13 electrons. Hence, it has a configuration 1s2, 2s2, 2p6, 3s2, and 3p1. And here you see that aluminium here has 2 plus 1 valence electrons, which is 3. Okay, which other chemical property do they have? They are p block, right? They are p block, which tells us that their last electrons fill the p suborbital. Okay, apart from that, what about their reducing ability? Or before we talk about the reducing ability, how do they ionize? They ionize. Now, you know they have 3 valence electrons, right? And what does that mean? It means that for them to form a stable structure, it's either they lose those 3 valence electrons or they gain 5 valence electrons. So when you gain 5 electrons, in addition to 3, you form 8, and then you have a stable octet. So it means that they have 2 oxidations. It means they have 2 oxidation states, the +3 oxidation states or the -5 oxidation states, right? So it means that for group 3 elements, they rather lose their 3 valence electrons instead of gain 5 valence electrons. So they ionize by loss of 3 valence electrons. And what do they form? A tri-positively charged ion. So they form a cation because they lose electrons. But what kind of cation? A tri-positively charged ion. They ionize by loss of 3 electrons, which is the 3 valence electrons they have, to form a tri-positively charged ion in their solution. So let's see the reaction of boron. So boron here in its solid states loses 3 electrons to form boron ion, right? Which is a tri-positively charged ion. Aluminium here ionizes by loss of 3 valence electrons to form a tri-positively charged ion. And that is it. Okay? What about their reducing abilities? They are reducing agents. Fine. And why are they reducing agents? Because they lose electrons. They ionize by loss of electrons. But when you compare them to groups 2 and group 1, they are the poorest reducing agents of the 3 groups. So they are the poorest. They're the poorest reducing agents of the metallic group. Is it metallic group or metal group? Of the metal group. Okay, so that means of groups 1, 2, and 3, they are the poorest reducing agents. They are the weakest, while groups 1 elements are the strongest reducing agents. Okay, what other property do they have? What can we say about their triazocarbonate phosphates? Please, this is super important to know so you don't write wrong equations in chemistry. The triazocarbonate phosphates of group 3 is inexistent. So there is no compound like aluminum carbonates. There is no such thing as aluminum carbonate or boron carbonates. The carbonates of group 3 are inexistent, just as the hydrogen carbonate of lithium is inexistent. So there is no such compound as hydrogen carbonate of lithium or carbonates of group 3. So their trioxocarbonate 4 salts, the trioxocarbonate 4 salts are inexistent. Right? So we don't know whether they're thermoresistant or thermolabile, since they don't even exist.